Right, today we'll see about binary multiplier and comparator. Right, so these are two leftover topics. So we'll see a binary multiplier, so which is a simple one. So generally the multiplication process will be like this, the normal multiplication process. So you can see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So normal multiplication process will be like this. So if I want to multiply this one, so B1 B0 into so A1 A0. Okay. So there is a process we'll follow here. So generally, if I take the values like so 1 into 1 0. Okay. So it is a 2-bit. So 1 into 1 0. If I perform normal multiplication, so what I have to do first here is, so I'll multiply this 0 into 1. Okay, so 0 into 1, and afterwards I'll perform again 0 into 1. Okay, so there's a first step here. Second step, I'll move to the left here. So next 1 into 1. Okay, and I'll perform 1 into 1. Again I'll perform 1 into 1. So 1 into 1. Okay, so here 1 into 0 is 0, and 1 into 0 is 0, plus 1 into 1 is 1. Okay, so 1 into 1 is 1. So the answer is 110. Right. So we'll get an answer of 110 here. So this is the process we'll follow. So if I take this as A0, and this is A1, and this is B0 and B1. So the process will be like this. The first thing is like A0 into B0. So that is first step here. And afterwards A0 into B1. Okay. And so that is the first thing. So multiplication with A0 is done. Next we'll go for A1. So this is A1 into B0, and this one is A1 into B1. Clear? Yes or no?
Yes, sir.
Like, so generally this is the normal multiplication process we'll follow. Okay, you can see here. If I perform B1 into B0, so first step is like A0 into B0 is done, and next step is like B1 into A0. Sorry, A0 into B1. Okay. Next again I'll perform A1 into B0 and A1 into B1. See the normal methods we'll get here. So the first step should be like this. The first we have to perform A0 into B0 operation. Next we'll have to perform this multiplication operation A0 B1 and A1 B1 multiplication operations. We have to use 2 AND gates and a half adder, and we have to add these two. Okay. In the third step, so we'll use another AND gate A1 B1. Okay, and another half adder which receives the carry from the previous half adder. Okay, so this is the method we'll follow. You can take this diagram. Okay, you can see here. This is C0 is nothing but so A0 B0. So that is the first step here. Okay, so afterwards A0 B1, so it's given to one AND gate, plus, so plus is done with the help of half adder. So A0 B1, so plus, so we are performing AND operation of A1 B0. So this A1 B0. So we'll add these two and we'll get these values here. Okay, and if I get any carry, so that carry will be given passed to the next half adder. So that half adder is added with the last value, that is A1 B1. is given to another half adder. So we'll get an external carry, that is C3, and this is the C2. That is the value that is arise from this half adder. Okay, if I take the example of this, so 1 1 into, so 1 0. Okay, so it is like 0 into 1. Okay, and this is so first of all we'll perform this, afterwards we'll perform this. Next we'll go for the second step here. Okay, so it is like 1 into 1. Okay, 1 into 1, and again this one into this one. Okay, so we'll perform this operation. So this is C naught, and this is C1, and this is C2, and if there is any external carry, we get the C3 value there. Okay.
Yes, sir.
Okay, now we'll see uh, a little bit lengthier one. So we'll see this is for a 2 by 2 binary multiplier. Okay, now we'll see a generalized format. Okay, so we have j multiplier bits. Okay, so j multiplier bits. Okay, and we have k multiplicand bits. Okay, so this is a generalized format here. So there is a j multiplier bits and k multiplicand bits. So when you have this j multiplier bits and k multiplicand bits, so we need j into k AND gates. So remember this. We need j into k AND gates. Okay, we need j into k AND gates, and j minus 1. So j minus 1 k bit adders. Okay, so j minus 1 is the number, so this number of k bit adders. So the number of bits, the size of the adder should be equal to the number of bits in the multiplier, so multiplicand. So whatever the bits in the multiplicand, so that should be the size of the adders, and how many number of these adders should be used here, so this is equal to j minus 1. Okay, and this will produce a product of j plus k. Okay, this will produce a product of j plus k. Okay, so this is the general one here. So if I want to take an example, okay, so I'll take j as 4, so which is equal to b3, b2, b1, and b0, and k as 3 here. Okay, so k as 3, that is a0, a1, a2. So we have 4 multiplier bits and 3 multiplicand bits. So totally we need 12 AND gates. Okay, so we need 12 AND gates, and j minus 1. So what is the value of j here? So j value is 4. So 3 k bits. So what is the value of k? K is 3 here. So 3 bit adders. Okay, so 3 bit adders. 3 bit adders in the sense we can use full adders generally, and to produce a product of 4 plus 3, 12 bits. Okay, so generally so we'll not have 3 bit adders, so we'll go for 4 bit adders here. So we'll be using this one's here. So we have to produce a product. Okay, so you can check this diagram. So we'll see the diagram, how the diagram will be. Okay, so take down this diagram. So 3 steps here. So first one is a0 is multiplied with all the bits of this one, and a1 a2 is multiplied with all the bits of this one. So and we have a 4 bit adders here. Okay, so 2 4 bit adders are used here, so in order to produce the sum here. Okay, so 1 minute. So I'll explain the process. right? So we need this. So wait. So I'll show you how the process will be. Okay. Uh, so if we have the value of 4, this one, right? So what are the 4 values here? The values will be like this. So B naught. So B3. So B2, B1, and B naught. Okay, and now we have the values of so A2, A1, A naught. Okay, the multiplication process will be like this. Okay, first of all, A naught with all the values here. So A naught, so B naught, A naught, or else I can write like this. So A naught, B3. So A naught is multiplied with all the values. So next A naught, B2. So A naught, B1, and A naught, B naught. And the next to the left, move to the left. Next A1 is multiplied with all the things here. So A1, B3. So A1, B2, and A1, B1, and A1, B naught. Next, it is moved to the left. We perform A2. So A2, B3. So A2, B2, A2, B1, and A2, B naught. Okay, so this is the first C1 value, and this is C2, this is C3, this is C4, and C5, and this is C6, and if I get any carry, we'll have C7. Okay, so this is the first C naught. Yeah, so this is the first value here, and next we have to perform addition of these two, A naught B1 plus A1 B naught. Next we have to perform addition of these three, A naught B2 A1 B1 plus next addition of these two, and next this one, and last one is external carry here. Okay, so this is implemented with the help of this circuit. Right, this is implemented with the help of this circuit. You can check here. So A naught, B naught is the first C1 here. You can see it's C1, sorry, C naught, C naught or C1, so whatever the values. So totally we get 7 bits here. So C1 to C1 and C7 and this quantity, like to C naught to C6 and this quantity, no problem. Okay, and so this is the first step here. So A naught and B naught, that is C naught. Next A naught B1 plus A1 B naught. So this is the first output we'll get here. So that is C1. You can check here. Confusion, okay. So what is the first step? So A naught B naught. So that is C naught here. Okay. So second step is you can check here. So A naught B1 plus A1 B naught. So that is the second C1 here. So that is done here. So we had to add with the help of adder here. So you can check here. So A naught B1. So this is A naught B1 plus the first bit like A1 B naught. So A1 B naught. So these two are added and the output is here. This is A naught B1 plus A1 B naught. Okay. So next addition should be this one. So next addition should be A naught B2, A1 B1, A2 B naught. Okay, so this is a naught b2, fine. The next a1 b1. So these two are added, and these two additions are given to the next adder. You can check here. So those two are added, and that is given to this 4-bit adder. So that 4-bit adder is added to this a to b naught. So getting my point here, so I can check this diagram here. Okay, so we have to add a naught b2, a1 b1 plus a2 b naught. So a naught b2 from the first stage, a1 b1 from the second stage, and a2 b naught from the third stage here. Okay, so first of all, these two are added with a 4-bit adder. Okay, and this again the summation of these two will be added to the next one here. You can check here. So first stage, so what we are doing here, so this is a naught b1. Okay, and this is done. Next a naught b2, the second bit, and here the second bit should be added, that is a1 b1. Okay, and this summation will be given to the first bit of the next adder here, and this first bit and this first bit are added. So what is this first bit here? This is a21 b naught. So a2 b naught plus summation of what is this value here? This value is nothing but, so a naught b2 plus a1. What is the value here? It is a naught b2 plus a1 b1. This is a1 and b1. So these two are added, and these two are added, given to this one, and plus addition of a2 and b naught. So the first bits are added here, so a2 and b naught are added here. Okay, so here the last bit is 0 here because 7-bit adder, so we'll use two 4 bits here, so there is no need of using the last bit here, so we are putting it as 0 here. Clear?
Yes, sir.
Okay, and it will follow this method here. So you check if you want, if you have any doubts, you can remember this, but if you have any doubts, you can follow this one. So this method. So next addition will be this one. From the first adder, we'll add these two. From second adder, we'll add summation of this one and this one. A naught b3 plus a2 b2 are added in the first adder, and the sum will be added to the a2 b1. Okay, in next phase, a1 b3 a2 b2 will be added here, and the last one a2 b3 will be added here. Okay, so this is how we'll follow. So we'll have two 4-bit adders, 12 AND gates. Okay, and to produce a sum of 7 bits here. Okay, so you're asking it like it'll be asked like 4 into 4 also sometimes. Okay, so 4 into 4 bits, or so you have to apply that formula and use this AND gates and adders here. So whenever you are given the higher adders here, so you have to use that formula and use AND gates and the adders in order to perform these operations. So first of all, do these operations. Okay, so to understand which phase which operation should be performed, and you have to draw the diagram accordingly. Clear?
Yes, sir.
Okay, and next we'll go for comparison. So how to compare? So compare it, when we compare any two results here, any two numbers. So we are comparing any two numbers. So we have three possible results. That is A is equal to B, or A greater than B, or A less than B. Okay, so three possible results are possible here. So when I take two values here, so A is equal to B. Okay, when I take two possible values, when I take two possible values, we have possible values of A equal to B and A greater than B, A less than B. Okay, so if A is a 4-bit, like, so A3, so A2, A1, A0, and we have B3, B1, B2, and B0. Okay, so when will we say that these two are equal? So A3 and this A and B are equal, and eppudu cheptam manam? So when we can say that A and B are equal here? Okay, so for this we have to check a formula here. So A is equal to B. Okay, so whenever if I say that this formula, so xi is equal to ai bi plus ai bar bi bar for I is equal to 0, 1, 2, 3. Okay, if these conditions like x1, x0, x1, x2, x3, all of them are equal to 1, then we can say that A is equal to B here. Okay, all of them are equal to 1, we'll say that A is equal to B. So we'll see how that is possible. Okay, so what is the formula we got here? So xi, so I'll go with x naught here, that is A naught B naught plus A1 bar, sorry, A naught bar, so B naught bar, so that is x naught operation, so A naught B naught plus A naught bar B naught bar, so this should generate a value of 1. Okay, so if I take the values like 1, 1, 0, 0, and the value of B3, sorry, B2, B1, B0 is also equal to 1, 1, 0, 0. So what is the value of x naught here? It is so this is A naught and this is B naught, so 0 into 0 plus A naught bar B naught bar, so that is A naught bar will be equal to 1 and B naught bar will be equal to 1, so we'll get a value of 1, x naught is 1. Next, coming to the next one, so x1 is equal to, so A1 B1 plus A1 bar B1 bar, so the values will be like this. So A1 value is also 0, B1 value is also 0, A1 bar B1 bar will be equal to 1 into 1, so that is also equal to 1 here. And next, x1 value, that is now x2 value will be like this. Okay, so x2 value, x2 is equal to A2 B2 plus, that is A2 B2 plus A2 bar B2 bar, that is 0 into 0, so x2 also equal to 0, and in a similar way x3 also equal to 1. So now we have the value of x here, I mean the value of A is equal to B, the condition will be like this. So A is equal to B will be equal when x3, x2, x1 into x0 is equal to 1. So we got a 1 here. If any one of them is 0, so what happens here is, so AB, so A2 into B2, so 1 into 0 plus 0 into 1, so we'll get a 0 here. So all the result will be equal to 0. So each and every bit is compared here, each and every bit should be equal to 1, so then all the coefficients x3, x2, x1, x0 will be equal to 1 aitene A is equal to B antam. Clear?
Yes, sir.
Yes, sir.
Okay, so next conditions we'll check for A greater than B and A less than B. Okay, we'll start the comparison from left to right here. So this is the condition for equality here, the condition for the equality. Next we'll check for greater than and less than. Okay, so the comparison should be like this. So this is the formulas used here. A greater than B ki ee formula use chestamu and A less than B ki formula use chestamu. I'll let you know. So what is this formula? Okay, so we'll start comparison from left to right. So I'll take the values like this. So 1 0, so 1 0 and 0 1 1 1. Okay, so this is the value of A here, this is the value of B. Okay, so I'll use a formula here. I'll say that A greater than B, so when this equation is equal to 1. Okay, so equation rastanu equation, so 1 ane equation vaste I'll say that A greater than B, or else another case. Okay, the first case should be so this we have to compare this one. So A3 B3 bar here. So what is the value of A3? This is the value of A3 here. So A3 B3 bar here. Okay, so what is the value of A3 and B3 bar here? So A3 value is 1 and B3 bar is 0, and B3 will become 1 here. So 1 into 1 is a 1. Okay, so the first step is okay. So A is greater than A3 is greater than B. We'll compare each and every bit here. So we'll compare A3 with B3 here. So when we have this greater, so till A0 and B0, till we reach A0 and B0, so this should be equal to, I mean, this condition should be satisfied here. Okay, so here the formula is like, so A3 B3 bar, so that is first case here. Okay, and the second case we have to check here is X3 into A2 B2 bar. Okay, so what is the value of X3? So generally X3 is nothing but X3 will be like this. So X3 is earlier we have seen, right? So there is A3 B3 plus A2, sorry, so A3 bar, so A3 bar B3 bar. I mean, this will say that these two are equal. So the values of A3 and B3 are equal, and eప్పుడు చెప్తామంటే if this condition moves to the next case here. So if I say that if we take the values of this one, if I take the value of, like, in case, so if I use a value of 1 here, okay, if I use a value of 1, so what happens here is, so A3 B3 will generate a result of 0. Okay, will generate a result of 0. So the meaning of this is, we'll say that, so these two are equal. So equality condition ela telustundi manaku with the help of these coefficients. So X3 is equal to A3 B3 plus A3 bar B3 bar. So we should get the value of X3 is equal to 1. So that will prove the equality. Okay, so next I will check the values of, okay, I'll check the values of, if this is the case here, I'll check the values of A2 bar, sorry, A2 B2 bar. Okay, so X3 is 1. Now value of X3 is 1 here, because A3 and B3 are equal to 1. So 1 into A2 and B2 bar. So A2 value is 0. Okay, so A2 value is 0, and B2 value is 0 here, we'll get a 1 here. So 1 into 0 into this one. Okay, okay, wait, yeah. Okay, so X3 into A2 B2 bar. Okay, next third case is, if these two are equal. Okay, so here also the second case is also true here, so we'll get a 0 here. Okay, because the value of X3 is 1, we know the value of X3 is 1, but the value of A2 and B2 bar, A2 is 0 and B2 bar is 1, so again we'll get a 0 here. So 0 plus 0 plus, I mean, what we can say here is, we'll say that A3 is equal, A3 B3 is equal, and A2 B2 is equal. Next we'll go on checking for the next value, X3 X2, and we'll get a value of A1 B1 bar. Okay, so X3 is already 1, and in the same way X2 is also equal to 1, because both are equal here, and A1 and B1 value. So we'll get a value of A1 is 1 and B1 is 0 here. So we'll get a value of 1 here. So 0 plus 0 plus 1 plus the next values we are least bothered. Okay, because we'll get a value of x1 as 0, because they are not equal. So we'll get a value of x3 x2 x1 as 0. So here we'll get a value of 0 here. So totally we'll get a value of 1 overall. Okay, so I'm substituting these values in the formula. So if I get a value of 1, then we'll say that A is greater than B. If I get a 0, then they may be equal or less than. Okay, they may be equal or the less than. So, and if I want to check the case for the less than condition here, so here earlier what we have done here. So here we have done A3 B3 bar. So we'll see A3 bar B3, okay, and A2 bar B2, and A1 bar B1 bar, okay, and A bar and B0 bar. Yeah, I don't know what is this N. Maybe this typing mistake. Okay, so there is a typing mistake. This is not there. And here also there is no complement here. Okay, so take these equations. So A greater than B. So you can check the examples here. Like so 1001 is 9, and if I say that so 1000, okay, so it is 8 here. So 9 is greater than 8 here. So we'll get this one as 1 here. Okay, and if I substitute in this, we'll get a value of 0. Ikkada 0 vastundi, ikkada 1 vastundi. Okay, and if I take the values of A as 0 1 1 0 and the value of B as 0 1 1 1, okay, I'll get the value of A less than B as 1. Okay, so this will be equal to 1. So when A less than B equation is 1, I'll say that A is less than B. When this is 1, I'll say that A is greater than B. When this is equal to 1, I'll say that it is A equal to B. So there is a condition for A equal to B, and there is a condition for A greater than B, and there is a condition for A less than B. Okay, so this is the case here. So last one, remember this x3 x2 x1 a1 sorry a naught bar and b naught here. Okay, a naught bar plus a naught bar into b naught. You can check the examples and you can do that. And x3 values and x2 values will be from the formula of this one. Clear?
Yes, sir.
Yeah, sir.
Okay, and yeah, so this is the case, and with the help of these equations, we have to draw the logic diagrams. Okay, with the help of these equations, to draw the logic diagrams, and this will be like this. Okay, you can do like this, or you can use the normal method what we follow. Okay, so this is the values of A less than B, A greater than B, and A equal to B. Okay, so A equal to B is nothing but x0, x1, x2, and x3. Okay, you can check these values here. So what is the value of x0 here? X0 is nothing but so a0 b0 plus a0 bar b0. I mean so b0 bar. So we have to add these two values. Okay, so a0. Okay, so the values of x0 will be like this. So x0 is equal to so a0 b0 plus so a0 bar b0 bar. Okay, so a0 bar b0 bar. So this is we'll get here. So a this is the value of a is equal to b. So it is a is equal to b is equal to wait. So a is equal to b ఎప్పుడు వస్తుందంటే so x0 x1. So this is XNOR gate here. So this is XNOR operation, and this is the XNOR gate. This is x2 and x3. All of them are given to the AND gate here. And this is A greater than B. This is the equations what we get here. Okay. So these are the equations. So when we see this equations, we have the equations here. Okay. So that equations. So we can do that. Okay, so you can take this diagram and implement that comparator operation. So generally, what is this performed here is, you can check here. So what is the output of this one? So A naught is given to inverter. So I'll get a naught. This is A naught bar, and we'll get a B naught here. And here I'll get, so A naught, B naught bar. So actually this is exclusive OR operation. Okay, so the values are given to OR gate అయితే exclusive OR operation వస్తుంది. And what is exclusive NOR operation? It is the inversion of XOR gate. Okay, inversion of the XOR gate. So that what we can do here is, so A naught, B naught bar, and A naught bar, B naught. So this is actually this is the output of OR gates. I mean, if I give it to OR gate, this is the output. But it is a NOR gate. So if it will go for inversion here. So when I take the inversion, what happens here is it will perform XNOR operation. So XNOR operation is like, so A naught, B naught plus, so A1, sorry, A naught, B naught. A naught bar, B naught bar. So this is the XOR operation. So XOR operation is inversion of XOR operation. So XOR operation is this one, A naught, B naught bar plus A naught bar, B naught here. So if I perform inversion on this, so I'll get this operation. Okay, so that is the meaning of this circuit. So it is given complex, but it's okay, fine. So you have to understand it. Clear?
Yes, sir.
Okay, so ఇదంతా XOR operation, ఈ inversion రానంత వరకు. Okay, so inversion is there, it will become XOR operation. If I use a OR gate, it is a XOR operation. Okay, so till every OR gate, so till this OR gate, so this one is a XOR operation. Okay, and if I do inversion, so what happens there? So it will perform XNOR operation. So that will give the values of x3, x2, x1 and x0. So that is the value of A is equal to B, and next the values of A greater than B will be equal to this values here. So the value of A greater than B will be performed like this. So A greater than B is this values, A3 B3 bar plus x3 into A2 B2 bar plus x3 x2 into A1 B1 bar and x3 x2 x1 into A0 B0 bar here. So that is the value of A greater than B. Okay, so these are the values we'll get when you are performing this operation. Clear? So you can check
Yes,
these
sir.
values. Okay, you can trace this. So what is this value here? So by tracing this, we'll get these values here. So check this value. It is this value. So what is this value here? It is B3 bar A3 and B3 bar. So this is the first case here. Okay, and the second one, so this one. So what is this one? X3. Okay, this is the value of x3 into this value. So what is this value here? So B2 bar A2. So x3 into A2 B2 bar. And if I trace this, okay, we'll get three values here. So what are those three values? This is x3 and this is x2 and this is the value here, x3 x2 into, okay, x3 x2 into this value. So what is this value? A1 B1 bar. Getting my point here?
Yes, sir.
Okay, and this value will be this one, x3 x2 x0 x1 x3 x2 x1 into A0 B0 bar. Okay, so that is A greater than B. So A less than B, so we'll get the different values. Okay, a circuit will is a little bit complex one, but you know, so this is the best way to draw the circuit, so you can prefer this. Okay, so or else if you want a general one, you can go for that general one also. So general you can use this method here. Wait. But for that you need x3, x2, x1, that also. So hence you can prefer this method only, because in order to get this x3, x2, x1 and x0, this is the best method, okay, to draw the circuit. Okay, so there's a 4-bit magnitude comparator. Clear?
Yes, sir.
Yeah, so wait. DLD syllabus. So we have seen the definition of combination circuit, we have seen the analysis part, we have seen the design procedures using binary adder, subtractor, decimal adder, we have seen the multiplier, we have seen the comparator, we have seen the code converters, BCD to XS3, there is 4-bit binary to gray code converters, gray to binary code converters, and different things we have seen. And we have seen the concept of encoders and priority encoders and the decoders part. Okay, so multiplexers, and the one thing left is demultiplexers. So demultiplexers is opposite of the multiplexers. I'll just explain. So we can construct the decoders with, demultiplexer with the help of decoders. So decoders using NAND gates will use the demultiplexer. Okay, so what is a multiplexer? It is a multiple input, single output. Okay, so coming to demultiplexer is a single input, multiple outputs. Okay, so single input, multiple outputs. So single input should be directed to the multiple outputs here. Okay, so that is the case here. So I'll show you. So a decoder with enable input. So this can be treated as a demultiplexer. A decoder which is constructed using NAND gates and the enable input. Okay, so enable input is the only single input here, so that is directed towards all the 4 outputs here. Okay, if I say that enable is a single input, okay, and we have selection lines A, B, so which are used to select the one of the 4 outputs here. Okay, so what is a multiplexer? So what is multiplexer generally? What is a multiplexer?
Combination circuit selects the binary information.
Yeah, multiple input, single output. So with the help of the selection line, is a combination circuit, so which is used to select usually have multiple input lines and a single output line. Okay, and the output is equal to one of the inputs here, and the selection of outputs is based on the selection of inputs is based on the selection lines here. Okay, so we have the multiple inputs. Okay, and with the help of these selection lines, we'll select one among these inputs here and direct it towards the output here. Okay, so 2 power n into 1 multiplexer. The size is like 2 power n into 1. So where n will be the number of selection lines. N will be the number of the selection lines. So multiplexer is also called as data selector. It is also called as the data selector. And the opposite of this one is, so we have single output in case of multiplexer. So here we'll be having single input. Okay, we'll be having single input and multiple outputs. So what we have to do? So earlier some multiplexer low, we'll be having multiple inputs and a single output. So output will be one among the inputs here. Okay, so inputs evaithe unnayo, so dantlo edo okati output avutundi. So that is in case of the multiplexer. So demultiplexer will be having a single input, and that single input is distributed among the multiple outputs. Okay, so input is output at a certain condition here. You can check here. So enable is the single input here, so that is equal to 0. Okay, we'll be having 4 outputs here. So 1:4 demultiplexer. So D0, D1, D2, D3. Okay. So E0 is given to D0, and E1 is at D1, and E2 is at D2, and E is at D3. So eppudu E0 is directed to output D0. So when the selection lines AB is equal to 0, 0, we'll be having selection lines AB. So this 0, 0, the value of E is directed towards D0 here. Okay. So 0, 0 onnappudu, the value of input is directed towards D0 here, and remaining all are equal to 1, 1, 1. Okay. And if it is 0, 1, input is directed towards the second output, and if it is 1, 0, the input is directed towards the D2, that is third output, and if it is 1, 1, the input is directed towards the fourth output. Clear?
Yes, sir.
Yes, sir.
Okay. It is opposite of multiplexer here. So decoder with which is constructed using NAND gates and enable input can be used as a demultiplexer. Okay, can be used as a demultiplexer here. Okay, so what I have to do here is, so I'll not be taking the class tomorrow. So you be prepared with all the combination circuits. So the basic definitions. So what is the meaning of multiplexer, decoder, encoders? Okay. So what are the circuits? So half adder, full adder. So whatever the circuits you have, so we study the basics of those circuits. Okay. So next class I'll be asking you the questions regarding this combination circuits. So you be prepared. Like, so after that only we'll go for the next topic, because without these basics you can't understand the next topics. Clear?
Yes, sir.
Yes, sir.
I'll be giving the time tomorrow, so prepare for that. So I think most of the people are attending, but they'll put the things aside. So what I'll do, I'll definitely ask the people. I'll ask you to turn on your videos, okay, and you have to answer the question. Okay, so next 1 hour session will be like question and answer. So if you have any doubts, you can ask. So maybe it may be 1 hour or 2 hours. I don't bother. But so without this concepts, so you can't proceed. Okay. So is this Bharat Kumar? So did I say that to drop your attendance? Cheppana and the Tondara? What is his roll number? Don't do kind of things. 262. So lateral entry, na? Right. So coming to next class, we'll be prepared for this. So I'll be setting the recordings today. You can check that. Right. You check that recordings, and so for question and answer session, Sarvata. So next, I'll not go for flip flops. So actually, I had to take the concept of flip flops, but it is this sequential circuits 1 and 2 will take a lot of time. So I'll continue these topics. But so meanwhile, we'll check this PALs and this one. So it will take hardly 7 to 8 or 9 classes or 10 classes. Okay. So we'll use this. We'll go for this 4th unit. Okay. So then we'll start the sequential circuits. So if possible, if the college starts, we'll start the sequential circuits in the college. So meanwhile, I'll finish this 4th unit. Right. So you can drop your attendance and you can leave.
Okay, sir.
Thank you.
Okay, sir.
Yeah.
అరే ఉమా, ఉమేష్.